pay attention. Today we're going to go over similar triangles and how to prove similar triangles. So I have a couple triangle similarity postulates up at the top there. The first one is angle-angle similarity. So we write that as a similarity. Okay, so angle-angle similarity. So on our picture, what that means is that you have this angle A and this angle X congruent. I know it's kind of hard to see that. And you have another angle such as this angle C and Z congruent. So within your triangles, you have two angles congruent to each other. That would make this an angle-angle similarity postulate. And then those two triangles would be similar to each other. The next one is side-side-side similarity. So write side, 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 and then similarity. For this one, your corresponding sides have to all be proportional. So AB to XY, those two corresponding sides there would have to be proportional to BC and ZY and AC and ZX. Okay, so each of those ratios created by those corresponding sides would have to equal each other. So if one of them is 2 to 3, all of them have to be 2 to 3. If one of them is different, then those two triangles are not similar. Okay, then the last one is a side angle side similarity. Okay, for this one, you have to have one pair of angles congruent. And in my picture here, that's angle A and angle X. So one pair of angles have to be congruent to each other. And then two pairs of corresponding sides have to be proportional. So in this case, it would have to be AB to XY. Okay, those two sides. And AC to XZ. So the reason I didn't include BC to YZ is because this is a side angle side similarity, meaning your angle has to be between your two proportional sides. Okay, so my sides here, AB to XY and AC to XZ, again, have to be that same ratio. So again, if one of them is 2 to 3, the other also has to be 2 to 3. In order for those to be similar triangles. Okay, questions on those before we go through some examples? All right, so in these first couple examples here, we want to determine whether the triangles are similar. If so, write a similarity statement and explain our reasoning. So the first one here, these arrows in these lines mean those are parallel. Okay, so if I have these lines parallel and this line as a transversal, I can find congruent angles within those two triangles. So I know angle X and angle W have to be congruent to each other because they are alternate interior angles. Again, given that these are parallel lines and this is a transversal. Do I have another angle that I can say are congruent to each other, another pair of angles, given that picture, just by looking at it? which angles would be congruent to each other? Come on, you know this one. I can say these two angles here are congruent. What type of angles are those? They have a special name. Be nice if you participated. These are vertical angles. Okay, vertical angles are always congruent to each other. So if you have two intersecting lines, those angles created across from each other are congruent. So now looking at my picture here, are these two triangles similar? Yes, they are. Which one of my three postulates would prove that these are similar? The AA one. Okay, these two triangles are similar by angle-angle similarity. Now that I know that they are similar, I want to write out the similarity statement. So I'll write out triangle XYZ is similar, not congruent, do not write the congruent symbol, similar to triangle, since I started with X, I'll need to start with W. I went to Y, so I'll go to V, and then last to Z. Okay, so if I can prove these two triangles congruent, or two triangles similar, I have to write out that similarity statement. Questions on the first one? All right, second one. When I look at these two triangles, I have both of them at a 90-degree angle here, right? So those two angles are for sure congruent to each other. So next, since I already have one angle congruent, I'm going to start looking at the sides surrounding that angle. So I'm going to look at this side here. 3, and this side here. And my other side that surrounds that angle would be AC and EF. So with this, I want you to notice how in this triangle I have two measures here, but in this one I only have one. I want to find this. I want to find this length. If this is a right triangle, how can I find the length of that side EF? If it's a right triangle, how do I find the side of one of my right triangles if I'm given the other two? There's a poster of it in this room. The Pythagorean theorem.
I guess that.
So I can take 6 squared plus x squared and set it equal to 10 squared. So I have 36 plus x squared is equal to 100.
Oh, God.
So x squared is equal to 64. So x is 8. So that side EF is 8. So now in order to show that these two triangles are similar, I need to write out the ratio of my corresponding sides. So that's why I highlighted these. So AB to DF would be 3 to 6, which is also what? If I reduce that. Okay, then I need my ratio of AC to EF. AC is 4, EF is 8, which is also 1/2. So now, since both of my pairs of corresponding sides have the same ratio, and I have an angle congruent between those sides, which one of my postulates at the top says that these two triangles are similar? It would be by side angle side. Okay, you have your angle between your two corresponding sides. So by side angle side similarity, then I want to write out my similarity statement. So we'll have triangle ABC is similar to triangle FDE. Okay, and that would be your answer for number 2. But you do need to check those corresponding sides. Questions on number 2? All right, then I'm going to look at number 3. So in this one, I'm not given any angles. I don't have any freebies to find congruent angles. But I am given all the side lengths to this one. So this one's looking more and more like a side-side-side similarity. But I still need to test out each corresponding side's ratio to see if they're all the same. So with my corresponding sides, if I look at this bigger triangle here, my largest side is V to U. To find its corresponding side on my other triangle, I need the largest side on this one. Well, that would be FH. Okay, so those are my two corresponding sides for the largest. Okay, my next largest side in my first triangle here is 8. And my next largest side in my second triangle here is 5. Okay, and then my last side, my smallest side in both triangles would be TU and HG. Okay, it does kind of help to highlight your sides so you know how to write out your ratio. So my yellow goes with yellow, blue with blue, pink with pink. So writing out my ratios for my corresponding sides, I have VU over FH, which is 12 over 8. And I can reduce that fraction to 3 over 2. Okay, so that was my yellow highlighted section. If I look at my pink one, that would be TU to HG. So 6 over 4. Again, I can reduce this to 3 over 2. So far, so good. My last one is the blue highlighted one. That is TV to FG, which is 8 over 5. Now, I can't reduce 8 over 5. So looking at all 3 of my reduced ratios, are they all the same? No. Since they're not all the same, these triangles are not similar. Okay, so you do need to test those out to make sure your triangles are similar. In this case, they were not. Okay, questions on number 3, how I lined up the sides. Okay, I took the biggest side from both. Those ones would be your corresponding sides. Smallest from both, those would be corresponding sides. All right, I want you guys to do number 4. So this one is looking more like a side-side-side similarity. Test out all the sides, make sure they're the same ratio. Okay, so do number 4, please.
Number 4.
What'd you give me after I said pray?
What?
I said the Pythagorean theorem when you gave me a look.
I didn't hear you say
You
Pythagorean
had
theorem.
God, you look so mad.
Me?
Yeah.
It's because nobody's doing what I asked them to do.
I'm doing it. Like, I'm already
I already did it.
It's I think it's fine. I don't know. Maybe it's from my highlighter. I'm waiting for them to scroll off. I took it off. That's me.
I gotta give it some time.
We'll rest. So
All right, so I do have number 4 up on the board, and I highlighted my corresponding sides. So the biggest with the biggest, smallest with the smallest. So I set up each of those ratios for the corresponding sides and then reduced it. When I reduced it, all 3 ended up being 5/2. So since all 3 of your corresponding sides ratio is 5/2, these 2 triangles are similar by side, side, side similarity. And I can write out my similarity statement to say that those 2 triangles are similar.
Do we have to write the triangles? Because I just keep writing past it.
I mean, I would prefer you to write triangle. Okay, questions on how to determine if 2 triangles are similar? All right, then looking at numbers 6 and 7 here. In number 6, we want to find KL. So KL is this length right here where X is. So the first thing I want to do is make sure that these 2 triangles are similar. So they are similar by angle, angle similarity. So angle X and angle J are congruent, and angle Y and angle K are congruent. So that means since 5 is between this angle and that angle, and 4 is between this angle and that angle, those 2 sides there are your corresponding sides. So you can set up a ratio of those 2 sides to help you solve for X. Now since I'm solving for this X value here, the side similar to that one would be side YZ. So with these ones, you want to set up a proportion to solve for X. So I'm going to go from the larger triangle to the smaller. And I have a ratio of 5:4. Well, since I started with my larger triangle here, again, I want to start with my larger triangle. That length would be 15 over its corresponding side, which is x. So when you're solving for one of the sides, you want to set your ratios equal and set up that proportion. If you're just seeing whether they are similar triangles or not, you need to just find each ratio and reduce it and compare them. So for this one, since I'm finding a side length, we set up a proportion. From here, I just have to cross multiply. So I get 5x is equal to 60. Divide by 5. And that x value will equal 12. And since I was finding KL, which is just x, I can say KL is 12 as well. Okay, looking at number 7, we want to find VS. Okay, that's this length at the bottom here. Now, there are two triangles within this larger triangle. So I have one that's QVS, okay, and I have a smaller triangle here, RTS. Now, those two triangles are similar because they share this angle S in common, and they both have a 90-degree angle. So those two triangles would be similar by angle-angle similarity. Now, if this is really hard to look at, what I would do is take your triangle within and move it out to the side here. Okay, so this is triangle RTS. TS is 12. RT is 3. Okay. Now all I have to look at for this larger triangle here, I don't need to look at this piece anymore or this piece. I can just look at the entire length of VS and QV. Okay. So since these two triangles are similar, I can take their corresponding sides. So that would be QV and RT. And VS and TS, and set up a proportion with those sides. So from my larger to my smaller, I have a ratio of 5 to 3. Since I started with 5, which is in my larger triangle, I need to start with that entire length VS here, which is X, over this corresponding side in my smaller, which is 12. Okay, and from here again, all I have to do is cross multiply. So I have 5 times 12 is 60, and 3 times X. Divide both sides by 3. X is 20, which means VS is 20. Okay, so if you see a triangle within another one, sometimes it helps to pull the smaller one out and redraw it just so you can compare your sides a little bit better. Okay, questions on that one? No, it's the same thing. No. All right, then on the back, you can use similar triangles to find measurements. So this first example at the top here, you're already given that these two triangles are similar. So we want to find the value of X and Y. So in both of these triangles, I have side BC and EF as corresponding sides. And both of those have a measure. So I can use that ratio of sides to find X and Y. So I'm going to solve for Y first just because I know it's a little bit easier. So So y is along this side AB. Its corresponding side is DE. Okay, so I'm going to set up a proportion to solve for y. So to do that, I'm going from my larger triangle to my smaller. So my ratio of similar sides here would be 18 to 9. Then since I started with 18, or my larger triangle, that means I have to start with the larger triangle again. So that would be y over its corresponding side, which is what? What's y's corresponding side? 18. To solve for y, I just need to cross multiply. So I have 9y is equal to 324. Divide by 9. And y is 36. Now I still have to solve for x. Okay, and x's similar side is 18 times the square root of 3. Okay, so those are my similar sides there. Now I'm still just going to use my first ratio I found. So I have 18 to 9. To solve for x, since I started with 18, which is my larger triangle, then I'm going to start with the larger triangle here, which is 18 square roots of 3. And that'll be over its corresponding side, which has to be x. Okay, from here I just want to cross multiply. So I have 18 times x equals, when I cross multiply with a square root, you just need to multiply your two numbers out front. So 9 times 18 is 162, and I'm going to leave the square root of 3. Okay, and then to solve for x, you're just going to divide both sides by 18. So all I have to do is take this 162 and divide it by 18, which is just 9 times the square root of 3. So honestly, the square root of 3 shouldn't even bother you. Okay, it's just like an extra number there.
My brother.
Okay, so you still solve the exact same. You don't need to multiply the square root of 3 through. Just leave it as is. Multiply the numbers outside the root. Okay, questions on example 1? All right, then I'm going to skip example 2 and we're going to go to the bottom here. All right, so ones on the bottom that I want to go through are number 3. So we're going to do number 3. And we want to find side BC. So we want to find this length here, that's x. Well, first I want to identify my similar triangles. So just like the first problem we went through, these lines are parallel. If you have parallel lines, you can always find those alternate interior angles or corresponding angles that are congruent with those lines. So since these are parallel, if this line CE is my transversal, then angle C and angle E are congruent to each other. Okay, so angle C and angle E are congruent. And I have vertical angles here again. So my vertical angles are congruent. So this will help me figure out which sides are corresponding sides in each of these triangles. So if you look at where x is, okay, I'm going to highlight in pink the best I can here. So x is BC right here. That x is between your two congruent angles, right? So its corresponding side should be between the two congruent angles. So what measure would x's corresponding side be? Which one in triangle BED is between two congruent angles? BE is x's corresponding side. Okay, so you do want to try and look for those congruent angles. Since x is between your two congruent angles, its corresponding side also is between your two congruent angles. The other side that I want to use to set up my proportion would be side AC and ED. Okay, so I can use those two measures to set up an equal ratio. So if I go from my smaller triangle to my larger, I have 30 to 60. Okay, those are your corresponding sides there. That's equal to, since I started with 30, what should I start with in my equal ratio? Started with 30. What should I start with in my other ratio? X over its corresponding side is 38.6. You're setting up equal ratios. I went 30 to 60. Those are corresponding sides. Then since I'm solving for x, I want to include x in my ratio. So I'd set it up as x to 38.6. From here, I just want to cross multiply again. So I have 60 times x. And then 30 times 38.6. 1,158. And then I want to divide by 60 to get x is equal to 19.3, which happens to be BC. Okay, the next one I want to do is number 4. Number 4. We want to find the length of LM. Okay, with this one, it's kind of like the one we did on the front where there was a smaller triangle within the larger. So you can take the smaller one out just so it's a little bit easier to look at. Okay, that would be triangle LPM. And then length LP is 7.2. LM is X. And PM is 16. Now for my larger triangle, I need to identify my corresponding sides here. So LM in my large one corresponds to, in my large one, KM corresponds to LM in my smaller one. And in my larger VM corresponds to PM. So for my larger triangle here, I need this entire length. What is that entire length? If KL is 9 and LM is X, what would their entire length be? Close. 9 plus X. What? Same thing on the bottom here. you need that entire length. So what would that entire length have to be if it's 16 and 8? 24. So you notice how in this bottom one, all you did was add? That's what you have to do in the top two. You just add the two measures together to get 9 plus x. So now I have my corresponding sides, so I can set up that proportion. So if I go from the larger to the smaller, I have 24 to 16 equals, again, starting with your larger, what's 9 plus x, over the smaller corresponding side, which is what's the smaller corresponding side? X. From here, we're going to cross multiply. So we have 24x equals 16 times the quantity 9 plus x. Make sure you write out that quantity. You need to distribute that 16 to both terms. Okay, so I'm going to come up here. So we have 24x is equal to 16 times 9 is 144. Plus 16 times x is 16x. Subtract 16x from both sides. So I have 8x equals 144. Divide by 8. And x is 18. Which means LM is 18. Okay, questions on number 4?